So, first, you all know that, but I wanted to start with that. Why we are doing clinical trial? Because placebo effect is useful in that context. A clinical trial is there to distinguish the effect of a drug on a target condition and to distinguish the effect of this drug from other influences. The first one is the spontaneous change of the course of the disease. The second is the placebo effect, and the third one is the biased information. And these three are supposed to be controlled via the randomization. So why dealing with the placebo effect if just randomization? We have no more problem in the trial. So the first point is to optimize the design of a trial, in particular at the step of the sample size calculation. If we, when we calculate the sample size for a trial, we have plans about the effect of the drug and plan about how the control group will evolve. And if we don't consider the placebo effect, then we have a chance, not a chance, we could, a probability to underestimate the effect or overestimate the effect, and then underestimate the number of patients included in the future trial. So it's really important to know what is this placebo effect in that context, to take it into account. The other moment where I think it's important for the trial, we are going to go to trial with external controls. There is a FDA guidance for that. But if we have external control and we don't take into account the placebo effect, then we can have a loss of power. And for external control, we can consider clinical trials, natural history, or real-world data. And in the two last, they can be a placebo effect. The placebo effect is not considered. And so we can imagine to add it when analyzing this kind of trial. So to better evaluate the placebo effect, we first need to know him. And I have currently performed a preliminary meta-analysis of this placebo effect on Sarah, which is the outcome we have in this ataxia. These are really preliminary results, so I would like any discussion about that. And I thanks Emilien Petit, who is my statistician on the project. So what we have done, we have looked to three sources. The first one is at the bottom. We looked in clinicaltrial.gov, the trial with a mention of the scale for the assessment and rating of ataxia, which is SARA. We had a look to the recent review from Choi, which included 7 trials. And then we also looked to PubMed with the query about SARA with ataxia, not stroke, in a randomized trial. Putting everything together, we had 74 papers, different, and we excluded some first because there was no publication for the trial, these ones were from the clinicaltrial.gov. Some had no placebo group, some were not in the ataxia field, and I will show you the disease we considered in the next slide. For 2 of one, there were not trials, and for 2, there were no SARA data available, which allowed to analyze 24 different papers from different trials. So it's larger than the Choi paper. The problem is to have the SARA from this data. We didn't get the raw data. We analyzed only the data that are in the paper currently. First option, the SARA was available in the paper. So that was the SARA change was available. So that was perfect because we will be able to do the analysis. The second option, we had the SARA at baseline and at the one or several endpoints, and then we were able to calculate the difference, but we were not able to calculate the standard deviation for that context. The third option, we had a graph with the evolution, and then using a tool, it is possible to retrieve the data from the graph. And finally, on some paper, we had only the difference between the placebo and the treated arm. And in that case, it was not possible to have the information about the SARA change. In addition to the SARA, we extracted the number of patients in the placebo arm, the pathology, the trial duration, and the date of the trial. So that is the 14 trials that we found that are about drug intervention. The first one was in 2011 from Cuba on oral zinc in SCA2 patients with a relatively small sample size and a 6-month duration. And then you can see all the others. They are from various countries. The SARA baseline was intermediate, except for one trial where the patient were 9 in mean at inclusion, and the maximum was 24. We had various pathology, some in SCAS, some in FA, and some included one subtype of disease and other a mix of SCAS or even mixed ataxia. The sample size was really diverse, from very small sample size to quite large, with more than 100. And also the duration was really variable, with some very short trial with 1 month, or longer, with no trial had more than 12 months, and only 5 had a 12-month time, and none between 6 and 12, and you will see in the later in the graph that we have plotted only to 6 months. And you have the SARA change, which are variable, and we'll see that later. The second slide is about the trial about stimulation. Mainly, there are TDCS or TMS, and we can see that the duration of this trial are very, very short. Quite all are less than 1 month, and just 2 had a 3 months delay, and they are mainly on mixed SCAS and with a little bit more advanced patients. And finally, we found 3 papers about rehabilitation with very small sample size and from 2 with SCA2 patients and 1 with SCA7. So some results. It's interesting because the results are similar to what Christian showed, but with some differences. So here you have a graph with, in y-axis, the SARA change from baseline. On the top of the graph, you have a disease progression, which means the natural history, for instance. And on the bottom, it can be which can be the placebo effect, or at least an improvement while the patient is under placebo. The data for each study, and when you have a dotted line, it's because we have 2 time points for the same study, and the size of the dots is depending on the sample size. And finally, we have 3 colors: red for the drug, green for the rehabilitation, and blue for the stimulation study. And in black, you have the evolution of the mean SARA change across the 6 first months, which is not significant, with a correlation of minus 0.19. And when we removed the rehabilitation study, because in this study we don't have a blind group, the correlation is higher and quite significant. If we look at 1 year, there is an increase of the SARA of 0.9. I remind it's a mix of several different ataxias, and the maximum is 1.7 and the minimum 0.3, which is quite similar to the natural history. So this is quite similar to what Christian showed with the FARS. If we have short disease duration, we show an improvement of the SARA, but if we have longer follow-up, it seems that the SARA deteriorates as if the patient had no placebo in the context of natural evolution. Do not hesitate to interrupt.
Sophie, I have one question there. Sorry, maybe I was too slow, but do you think the differences you're showing there, is this a difference via the intervention or via the time scale, given that most of the, so for example, so you know what I'm asking is, yeah.
Is the difference between drug rehab and stimulation?
Is that the difference, or is the difference between the time scales? Because most of the stimulations have the shortest time frames, whereas, for example, most of the drug have the longest time frames. So what is the driving factor there?
I have the answer later, but I can show you. I have the answer here.
Okay.
We had the look between the, it's on the right of the panel, the right panel. You have the effect for drug, the rehabilitation, and the stimulation, and it's not significant. Even the longer trial are all in the drug group, and we have that outlier, and we mentioned, I have that in another slide. So it seems that it's mainly the duration than the kind of the type of intervention.
That's an important finding. Thank you.
Yeah. The other point we had a look, because Christian said that the placebo effect increased with time, with the date, the year the trial took place, and we have the same evolution here, and removing the rehab or not, the correlation are quite similar. So on the first, and we removed this outlier, which is orange zinc sulfate in Cuba, statue. So it's a really, really important improvement on the placebo group for this trial, which is quite different than the other studies. But we found the same thing, that the placebo effect is more and more important with Sarah, which is not a good point for the future trial, because if we, I don't know where the line will stop. Then we look to the value of the baseline, Sarah.
Sophie, sorry for interrupting. I'm just playing the moderator here. There was one, I'm monitoring the chat, so I'm assuming the moderator as well. There was one from Gülin.
Yeah, sure.
Yeah, how do you explain the date dependence?
The hypothesis is that as drugs are coming, patients think that they can have, I don't know exactly, but I think we already discussed that last time with Christian, or with, yeah. But I don't really explain, but it's common. It's not only in class.
Christian, do you have an explanation for this? Christian, I don't know whether you're online. Christian,
I don't know if we look at a disease where there are 20 or 25 years of trials, if where this line goes, because it cannot go to minus infinite. So you need to stop somewhere. So I don't know if we had 10 more years, if it will stop or increase. I don't have the data, and I'm not.
Yeah, so I suppose I don't have an explanation, but is it really the type of drug or the type of trial that is done? I mean, rehabilitation or stimulation, is this really the same placebo effect? So that's my first question. But even if we look only at the drug trials, maybe these drugs have just carried more promise to the patients. They're also the biggest ones. They're also the biggest ones, clearly.
Yeah, but when we looked, yeah, the last one or the biggest one, but and for the first comment about the type of trial, we see that we have also blue dots here and green there. So
yeah,
there is a mix. Not first the rehab, then the stimulation, and then the drug. There seem to be mixed.
There's a comment from Veronique.
Yeah.
Yes, it's just to say that over time it has been shown in depression. They follow during 20 years, and effectively the effect size becomes more and more important with the time. And it was explained because, you know, the take care has been changed over the years. And I think we take care of the patients, clinicians now take care of the patient, we provide much more care than it was 10 years ago, 20 years ago. And so that helps finally to have a higher placebo effect, potentially.
But where it stops?
I hope it will stop once, because of, yes, it's
because you have 20 years of trials. There we have only 10.
Veronique, is there only a plateauing happening in depression? Do you see anything, or is it still going on?
I think there is no follow-up anymore. No, you see. So, but it has been published, yes, and it has been seen. I think it was the European agency who made stock from the files they received over 10 to 20 years, and they said they saw it really over 10 to 20 years that it was constantly improving.
One more question is, Sophie, what Veronique just said, this intensifying taking care of the patients, adding to the placebo effect. Is that what you have been framing the cocooning effect, or is that still something different?
No, I expect it's the same, but
yeah.
But there is also the way the patients the clinician take care of the patients. There are new technologies, there are more information, there are a lot of other things than the cocooning, but
yeah. But this is just semantically, that is what you have been, the cocooning effect is this taken care of.
I'm not able to distinguish here in that study the cocooning from the other effects.
No, that ends on story. It's just a pure semantic question. Cocooning effect is the taking care of effect, independent data. Just
I think so, yes.
Yeah, okay, thank you. Thank you.
One more comment, Sophie.
Oh, yeah, sure.
I think what might be a little bit misleading here is the duration of the trial.
Yeah.
Because what you see in Friedreich clearly that it goes away at 1 year.
Yeah.
It depends, of course, on the trial because the diversity of patients is so big, but of course, in the most aggressive young patients, after 1 year, the natural history will just catch up with the placebo effect. And that is something that should also make a difference here between 3 months and 6 months. So
if we look to the
yeah.
If we look to the 12 months study, which are here in more dark color, they are from the first one was in 2012 and the last in 2017, and we see that the effects increase and then decrease, so with quite similar sample size. So
yeah, you could see that on your graph where you have the trial duration. I think you also had the correlation.
Yeah, but I've removed the 12 years
you can't really see
because
the 12 month here,
it was going up.
Yeah, that's the important point, I think.
Yeah, and we don't have trial with intermediate values, so I don't know what's going on between 6 months and 12 months because no trials had an endpoint at 9 months, for instance. So it was why I removed, because it was difficult to know what was going on from here, and then we are 0.9 is quite here. So we have a point here, but what is between, I don't know.
One more question from the chat. Tezenas is asking, did you follow randomization influence on placebo effect? For example, did 1-to-1 versus 1-to-3 randomization, might this give a different placebo effect? Did you check for the randomization effect of randomization on placebo?
No, I didn't.
With this, and I'm seeing Alex Swertlov as being part of the participants. Alex, you have been doing a lot of work on the randomizations in RCTs, not in Ataxia, but in other neurological diseases. Is this known from the literature, whether the randomization ratio does have an impact on the placebo effect? Alex, do you know?
Yeah, that's a good question, Matthis. I think it's not easy to answer. So it's yes and no. So I think it depends on what type of randomization, right? And depends on the assumptions that are applied. So I think if it's unequal allocation randomization, then it may be more problematic. If it's 1-to-1 randomization, then it may be better. Then it's also presence of the time trends in the data and some other assumptions. So I think the answer is it depends in general. Okay. So it may or may not.
Okay. Thank you, Alex.
Yeah, hello. Maybe I could comment a bit on my question.
Sure.
Yeah, just very short. I recall one discussions on one smoking cessation trial where the randomization were 1 to 3, so 25% only got placebo, and there was very much bigger placebo effect than expected, so which brought into problems, of course. And one of the speculations was that it might be that the expectations of the patients were more actually, and there was less chance to get into placebo. So that was. So I just wondering whether can be any follow up on that, because yeah, not sure how important, but
unequal randomization certainly makes things more complicated, and indeed there may be expectations on the patient side that they're more likely to receive the active treatment, and that certainly may affect the outcome, especially if it's not really the biological measure, so more objective. So if it's in psychiatry or depression, so that may affect. But then there are many other factors. It's whether the trial is blinded or open label, whether outcome assessors are blinded properly. So there's some evidence actually that all these factors separately, individually, or in combination may affect the placebo response and the effect of the placebo.
Thank you.
Thank you. Sophie, I think you can go on, move on.
Okay. We didn't look to randomization, indeed, and blinding. Most are blinded study, except the rehabilitation, indeed, because it's quite difficult to have a blinding in that context. We had a look to the baseline SARA value, following what Christian showed. There is a tendency that with higher SARA score, the placebo effect is smaller, but it's not significant. So it seems that it's less influent than with FARS in FA. And we didn't remove the FA patients there or stratified FA scars can be done, but we didn't. And lastly, we have seen already the type of intervention effect, but we looked at also to the continent effect. We just pulled the study between America, Asia, and Europe. And America is North and South America. There is a difference with the Asian study where the placebo effect was larger than in the two others. But in the European, there are all this long trial with 1 year, so it's increased. But even if we remove these points, the Asian are lower than the European ones.
Maybe, Veronique, you can ask it out loud, then it's maybe easier to understand for everybody.
Yes, it's just that Sophie said it should be nice to multiply the visits, but it has been shown that sometimes multiplying the visits might improve the placebo effect. And I don't know what to be done in case there is a learning effect on our clinical outcome. How would that impact the placebo? I don't know, it's just purely a question. But if we multiply the visits and that there is some way or another any learning effect, how will that interact with the placebo? I'm afraid it can even increase it more or reduce it. Finally, I don't know. Do you get my question? So,
yeah, sure.
But there might be no answer. I don't have the answer. Okay, so
I don't either. I don't know if there is a learning effect on SARA. I'm not sure, but I don't have the proof of that. Sara is used in the follow-up of the patient, at least in some centers. And yeah.
What would be the study or project we would have to run to answer this question, whether there's a learning in the Sara? So what we would need is we would have a high frequency repeated Saras in a short time frame and see whether there's improvement or not. And
but see, it can be learning, but it can be also variability of the patient. And from the paper from the Thomas team, they have shown that there is variability of the patients who.
But if the variability is higher than the potential learning effect, then more the variability is a problem than the learning, isn't? Would that be the conclusion there? That yeah. But this having said, so we still have to keep in mind that this was a Sara home paper, so it's not. Sara home is still something that's different than a real Sara. So there might be some comparison, might correlate, but it's still a different thing. But it's the best we have. Yeah. Rosa, you unblinded yourself.
I'm unblinded. No, I've always actually been curious about the learning effect in patients who are followed in clinic, so regularly followed in clinic versus, so if you're recruiting from your own clinic versus a trial that is getting referred, and again, without having access to data or collecting that information, I think it'll be very difficult to know. So if a patient is naive to the clinic, doesn't know that Sara, there may be more learning effect compared to someone who regularly follows up with the clinic, sees the same doctor every 3 or every 6 months, when there may be less learning effect.
Thank you for this comment. There is an additional comment from Kenya. Kenya, you want to speak it out loud, or you want me to read it from the chat?
Yes, could you read it?
Yeah, sure. Kenya is asking, Kenya would like to know if you have seen any association between the placebo effect on the one hand and the severity of ataxia on the other hand. He's saying in the double-blind study in Japan on govaletaline from Japan in 2020, they saw a larger placebo effect in the milder ataxia patients as defined by Sara less than 10 points, as compared to the more severely affected ataxia patients, Sara larger than 12. And he's even saying the authors are now planning the next study to be set in patients with Sara larger than 12, given that apparently those more affected patients had a less placebo effect. Sophie, 2 questions to you. First of all, did you see the same? And I think you had on one slide where you showed, I think, that the baseline Sara did not have an influence. Maybe you can go back to this one. And secondly, can you give this more general question from Kenya? Do you think, would you think that's a plausible approach, what this Japanese team is now planning to do for the next step?
That's the slide. On this slide, we plot the mean Sara at baseline versus the Sara change. And we cannot stratify because we don't have the raw data. That would be an additional analysis that could only be done on the raw data. So what I can see is that with a mean Sara score, there is no, with the sample size we have, there is not a clear correlation between the Sara at baseline and the Sara change, but it's only on the mean Sara.
But this having said, so Sophie, you could also phrase it differently. You do not find evidence that the milder affected patients do have a larger placebo effect.
Indeed.
Yeah. So Kenya, I think the response.
But you can see that the mean Sara score at baseline, we have one which is quite close of 0 pre-symptomatic, and the other one are from 9 to 20, and so it's difficult to have a clear answer from this analysis.
But you might even want to argue whether you should have included this green dot on the left side in there as well. I mean, taking the Sera in a population with the mean Sera of what is it, 1 or 0.8? What does the Sera do there? I mean, there's nothing you can. The Sera doesn't do anything there in this range. It's just noise. You mentioned it anyway. Anyway,
Christian has.
Yeah.
And
yeah. So I think there's several things obviously affecting the placebo effect. It's the severity of the patient, it's the genetic severity of the patient, and then there's these technical things, there's the time course that we see. And let's just look at those and see what we see in Friedreich. What is the strongest effect? And we clearly see the time course at 3 months, it's strongest, and then the natural history kicks in. It's stronger in genetically milder patients. I haven't looked at baseline scores. At least I don't remember now. Maybe I did, but and the strongest effect that is there is it only exists in appendicular items. So everything that ignores these it's doomed to fail. So I assume that the placebo effect in all these dots, or behind all these dots that Sophie is showing, is because of the appendicular items, not because of the axial tests. So
Sophie, you're not able to analyze this, right? Because you did not.
He's not. I know. I understand.
Yeah. No, but that's something. I mean, we could take home and then see. I mean, Sophie, that's something you should be working on in the next years to come. Really, we need to get access to the raw data and then run in particular this analysis, Christian. Yes.
And I have one more comment that is a little bit further away. So there is this fact that in the spinocerebellar ataxias and in the SARAs, patients are aware of their scores. We know that. They discuss them. They say, I'm at this level. I was last time I was at that level. I don't think that's a good thing. It will increase the learning effects, and it will have a big influence on the tests. And of course, the more often you do it, the more people will learn and the more people will remember. And that, I think, is something that should be stopped and not be done. It's a research tool. It's not something for a patient to assess himself or to know about himself. For that, a patient would have to understand the tool. And I'm not saying there are no patients who don't understand. Of course, that exists. But the majority of patients doesn't understand the variability in such a test and how much it is just going to be off because of the variability. But that's another aspect. I'm just saying less tests, less knowledge about the tool in a patient will increase these, will make these problems easier to handle. No patient knows their FAR scores. That just doesn't exist. They don't even see what they score.
Mm-hmm.
So the score is just given from the rater to the patient who enters in the CRF without the patient noticing it.
Yeah.
And I think that will help a lot with these problems, with a lot of them, not with all of them.
Yeah. Thank you, Christian. I have one question. My brain is too small to think it through, but having you, Christian, and Sophie on the call, let me try to get two knots together. What we have been seeing our recessive ataxia patients and Sophie in the autosomal dominant patient is that indeed at least the appendicular items might add some variability to the natural history progression of the Sera. Let's just assume. So we might not fully agree, but let's assume this. This is what
I'm not completely.
Yeah. Let's just assume for the sake of the argument, and that's one observation. And the second observation, Christian, which is what you're having, is that the particular items are also in particular more prone to the placebo effect. Now, are those two observations linked and causally linked? Is it because they are more variable, they are thus more prone to placebo effects? No. Is that a causal link, or is this a two independent phenomenon which might then even add up in a trial? Could you comment on this, Christian?
I don't see why they would be related or depend on each other. Variability and placebo effect are two different things.
I was thinking they're less biological and thus more prone to intervening effects like a placebo effect. That would be a mechanistic.
I think they are more prone to placebo effect because they are less natural things that people just don't do.
Yeah.
Okay. And they can train and then they get better.
Yeah. Okay. Mm-hmm.
But that's speculation. I have no clue. No.
Yeah. Yeah, thank you. There is a question from the chat from Rosa. Rosa, you want to ask it yourself?
Oh, I was asking kind of about the placebo effect and looking at other, looking at the experience from other people, if they could comment on if there are trials with long screening periods, like whether 4 or 6 months, and would that help with the placebo effect and learning? At some point, learning plateaus, I would imagine. Any comments?
No, I
anybody?
would impact.
Would you just make the study longer then?
Yeah, it makes the study longer, but for the patient itself, it don't increase the patient participation. So
The study is longer, but the type of study, the type of assessments done are less burdensome in the screening period, perhaps, than the actual trial itself. But again, this is just
you mean the screening period? The patient is screened and then it starts the study is
correct. Yeah. So
okay, because I didn't understand the screening period as I just understood the period where the clinician screen the patient.
Yeah, so during the time that they're recruiting, or screening, so oftentimes for the trial, there's ideally only 4 weeks or 6 weeks time point.
Yeah.
But I think I recall that in the Huntington's disease, the PTC, they have a very long screening / natural history study before the patients are entered into the actual drug trial. Right. And then there's also another stem cell therapy in Huntington's trial where they actually had a 3-year screening period, quote unquote. The patients are followed for 3 years before they're considered eligible for stem cells. So again, just wondering if that would improve the actual placebo effect during the trial itself. Because the trial itself is from the baseline.
Okay.
The baseline is the day 1 of active treatment.
Yeah. I think patients know where they started to be treated. So as placebo is coming most of the time from the expectation they have finally from the drug, I'm not sure, having a longer screening period might finally reduce your placebo effect. I don't know, but I think it's really linked to when you start to be treated. So I think yes, it could not help, but it's just personal opinion. Okay.
Yeah, and of course the concern is the actual effect of the placebo from the treatment. And I think we were talking earlier about, is the effect really the expectation of the patient, or is it learning? And so if it's learning effect that's accounting for the quote placebo effect that we're seeing, then we would reduce the quote learning effect with a longer screening period, perhaps, or more frequent assessments, during the screening period.
Yeah, interesting thought. Thank you, everybody. So we are getting close to the hour. This was the last session of this studio series so far planned. I have put in the chat the questions. If you guys have any further systematic question related to the placebo effect in ataxia, which you think we should discuss in another studio, please let me know. Either type it now into the chat or shoot me an email. And ideally, you would already have a speaker or an input presentation, somebody giving an input presentation on this topic, and then we could think about a 4th studio session within this series, which will likely still take place in July or after the summer break. So please let me know. With this, I would like to thank, first of all, the 3 speaker teams or input teams, the Xavier team, Roderick Mars from the first studio session, the second studio session. Thanks a lot to Christian. And for the third one, thanks a lot to Sophie for your time attending, presenting. This always takes time. It's extra effort. Thanks a lot. But then also thanks a lot to all the discussants. And what you could also see over the 3 studio sessions is there was a learning trajectory also in terms of participation. I enjoyed the studio today the most because we had the highest level of participation, of discussing. So I really loved this. Thanks a lot. I think we as a community are learning. Also, we are learning this format. Thanks a lot for your discussions, for the inputs. And I think we keep this, at least this series going, this studio series going. So if you have other topics to be discussed in the studio, not related to placebo, but any other methodological main problem in the Ataxia trial readiness field, we could and will host other studio sessions and series as the AGI, as part of the AGI in the next months, and we are open to your suggestions. Again, this was this suggestion from Roderick Mars and Xavier coming at a glass of wine at the last Dallas meeting. So please feel free to shoot me your suggestions and your ideas, and we will keep those discussions going. With this, thanks a lot for this discussion. Have a nice week.